Okay, we're going to talk about conversions today, specifically mole to gram and gram to mole conversions. So these are going to be one-step conversions, which means you're going to need a single conversion factor. So what does a conversion factor look like? Talk about that real quick. It's when you're going to have a value and you need to convert it into something else. So what you do is you write down the starting value. So let's say we have something kind of silly. So we have 55 dogs, and we've got to convert those dogs into something. So it doesn't matter what you're converting into, you are starting with the unit. So I'm starting with dogs, and I need to get rid of them. I don't know what I'm converting them into, but I got to get rid of them. So this is a conversion factor. Multiplication sign and a line. So think numerator, denominator, top and bottom. And what you're going to do is on the bottom of your conversion factor, whatever you start with, in this case, we started with dogs. That unit goes to the bottom of the conversion factor. So right down here, I'm going to put dogs. You then are going to put whatever unit you want on top. So let's say I want to convert the dogs into cats. So I can put cats up here. Again, very silly. If I know how many dogs it takes to get a cat, I can put that conversion factor in, and then I can do the math. Now, of course, we don't know this value. This is something that we don't know, but you would put a number here and a number here, and then the dogs would be on top and bottom, and they would cancel, leaving the unit that we want. This is what you want to focus on. Yes, this is silly, but whatever unit you start with, that unit must go to the bottom of the first conversion factor. And so that's kind of just an overview. So now we're going to look at this from a chemistry term where we actually have some values to look at. So let's go ahead and look at the second problem. We've got 2.4 moles of sulfur. So first thing you want to do is you want to find the number and the unit. So it's 2.4 moles of sulfur, and so that's the first thing we're going to write down. So I'm going to go ahead and write down 2.4 moles of sulfur. So I've got my number, my unit, and then I'll put my S for sulfur. Okay, we want to convert it into something, and it looks like we want to convert it into grams. So these are one-step conversions, so you'll need one conversion factor. So this is a conversion factor. It is that piece right there. It is the multiplication sign, the line, setting yourself up for a conversion. And so we have moles right here. So I'm going to get rid of moles, and they're going to go to the bottom of my conversion factor. So I'm going to put mole down here. And then the thing that I want is grams, and so that's going to go to the top. So I've got moles on top, grams on top, moles on bottom. And so now we need to apply some values, some numbers. We need a number here, and we need a number here. So where do we get those numbers? Well, right now, when you put mole into one of these problems, it's always going to have a value of 1. So you can just go ahead and put a 1 in front of the mole unit. And then the other unit, which is going to be the grams, that's going to come from the periodic table. And so grams is going to come from the periodic table. So what you do is you're going to go to the periodic table, and you're going to be looking up the value that we call molar mass. And that's going to be from the periodic table. So we just need to go find sulfur on the periodic table and take a peek at what that value is. So if we go over here to periodic table and take a quick look, you'll see that sulfur is right here, and sulfur is going to be 32.7. And so that's the value that we're going to use. And so let's go ahead and go back. So we got sulfur at 32.07 on your periodic table. We're going to go back, and we're going to go ahead and pencil that in right here. 32.07. And now you can run it through and get an answer. So the way it works is if a value is on top of your conversion factor, you multiply by that value. If it's on the bottom, you divide by that value. So kind of slide this down here. Let's go ahead and get an answer. And so we're going to go ahead and take 2.4 times 32.07. So for you guys, it's going to be in your calculator 2.4 multiplied by 32.07, and that will give you your answer. Again, I multiply because it's on top. So go to our calculator, 2.4 times 32.07, hit enter, and you get 76.968. So that's a lot of values, and so 2.4 only had two significant figures or two values. So let's just go ahead and round that to 77. So let's go ahead and round that to 77, and that's going to be grams of sulfur. And so again, the rounding piece, whether you've talked about significant figures or not, I base it kind of on the values we have in the problem. There's only two numbers there, so this is a good way to round your answer and to kind of keep it within a range that makes sense, not writing down the whole display. So let's go back to that periodic table real quick. I noticed that my pen wasn't writing on it, so let's just go back and make sure you see where I'm getting that sulfur value right there, 32.07. That's where that came from. So, all right, so we're going to go ahead and move to another problem where it's going to mean that you have to do a little bit more with the molar mass. Let's take a look here at number 20 because it has a couple of things of interest. It's got an exponential value, so just trying to show you how to put those into your calculator, and we're also going to solve for moles with a compound, not an element, so NH3 will have to be added up. So again, first thing is that I'm going to identify what I start with. I'm starting with grams, and looks like we're going to go to moles. So we're going to always write down the number and the unit first. So we have 1.2 times 10 to the third grams of our ammonia, which is NH3. So again, conversion factor, go ahead and draw that out. You're going to get rid of grams, so that's going to go to the bottom. So again, why is that going to the bottom? Because we have grams here, so we need to get rid of it. So it goes there. So whatever unit you start with, whatever unit is here, that unit is going to go to the bottom of your conversion factor, whatever unit is in that first spot. It just right away, on that silly example at the beginning, it was a dog. It could be a Tyrannosaurus Rex. It could be anything, a cloud. It doesn't matter. Whatever you put in this unit, put it at the bottom. It could be miles. It could be anything. So on the top, you're going to put the mole. And so on the other part of the conversion factor, if you put a unit on the bottom and it's not moles, moles goes on top. If moles are on bottom, it's going to have your other unit on top. But you will always have moles either on the top or the bottom of the conversion factor. And right now, you will always put a value of 1 in front of the unit for moles. Now, grams. This is going to come from the periodic table. We're going to have to look this up. So what we're going to do is we're going to find on our periodic table N, and we're going to find hydrogen, and we're going to have 3 of those. So let's go ahead and look those up real quick. So we'll slide over to our periodic table. And we've got nitrogen, 14.01, and hydrogen is 1.01. So that's where I'm getting these values. So let's go ahead and take a look. We're going to have 1 nitrogen, so that's going to be 14.01. And I'm going to add that to the 3 hydrogens. So 3 multiplied by 1.01. And so what we're finding here is called molar mass. And so we are finding a value that's referred to as molar mass. So we're just going to run that through our calculator real quick. And again, pretty straightforward. So 14.01, and I'm going to add that to 3 times 1.01 because there are 3 of the hydrogens, and you're going to get 17.04. So that's the molar mass for our ammonia. So we're going to go ahead and put that in. Okay, well, the bell rang there and interrupted, so just finishing these up real quick. So when we added all that up, that was 17.04. So that's going to go down here. So just drop in your 17.04. Now remember, want to do good bookkeeping on this. Don't take shortcuts. And if we look at our units, this is a good thing. We have grams on top and grams on bottom, and those would cancel. So we'll go ahead and do the math. It's going to be 1.2 times 10 to the third divided by 17.04, because see, 17.04 is on the bottom. Now, one of the things students kind of struggle with is how do you enter that in your calculator? So there's a couple of ways. You can do 1.2 double E3, double E meaning your exponent, your exponential. It's an exponential button on your calculator. You could do 1.2 EXP. This is what it looks like on your phone or on the Google calculator we look at. Or last option is you can do in parentheses 1.2 times 10 caret 23. A lot of students like the caret because they use that in math class, but you do need to use these parentheses because your order of operations can get kind of squirrely and you can get wrong answers without the parentheses. So you don't need the parentheses for the other two, but you do need it if you're going to do the caret. So anyway, let's plug it in our calculator. So let's go to our calculator and let's go so go back, see it's 1.2 times 10 to the third. So we're going to go 1.2. There's the EXP key. And I'm going to go 3. That means 1.2 times 10 to the third. The E means times and 10. And then if we go back, we're dividing by 17.04. So we're dividing by 17.04 because it is on the bottom. So we're going to go back over here and we're going to say divided by 17.04. And we hit enter. And we get that number with a significant amount of values in the display. So we're just going to take that to probably 70 because of the amount of numbers we have. So again, you may not have talked about sig figs, but if we look here, there's only 2 numbers there in our starting value. And so we don't really want a huge display. So we're going to go ahead and report a final answer of 70, and that's going to be 70 moles, and that was 70 moles of ammonia. So kind of key takeaways here: good bookkeeping, make sure that you have units on top and bottom so that they can cancel, and just kind of go slow as you go through the process. And so this should get you a good start on these. They're pretty straightforward. We're solving for molar mass. That's our periodic table value, kind of the thing that we were doing here. And then up here, just the idea of a conversion factor, whatever unit you start with, you always want that unit to go to the bottom. So if I start with moles, moles go to the bottom. If I'm going to start with something like grams, I know my first conversion factor, grams, are going to go to the bottom, and the mole always goes opposite. So that should get you started on these.